Hi, I'm Ho Yan Yu, and I'm going to talk about market survey for our product, biodiesel, and our raw material that involved in this production. So in year 2011, the demand of biodiesel is around 29 billion gallons, but in 2016, the demand had increased massively from 29 to around 45 billion gallons. So, according to this statistic, you can predict that the demand for future will be increased around 71 billion gallons in future. So, the biodiesel has been discovered many years ago, and the consumption started to increase since year 2001. As you can see, from year 2001 to 2015, the consumption of biodiesel increased extremely from 10 million gallons to currently 1.5 billion gallons. So, some research done by the EIA, which is the Energy Information Administration, in year 2012, the global consumption of biodiesel by around 64 countries is around 6.44 billion gallons, and this is the share of total consumption that in world. So this is the price of our product biodiesel, and this is a price list that for the national average price between 1st of April to 17th of April in year 2017 in US. So as you can see, there's two grades of biodiesel here, with B20 and B99 to B100. B20 is the blend of biodiesel with diesel fuel, where the 20 here is represented by 20% of concentration of biodiesel mixed with 80% of diesel fuel, where B100 is the pure biodiesel produced. So the price of B20 is around $250 per gallon, while B100 is around $3.1 per gallon, where after conversion to Ringgit Malaysia is around 4 Ringgit per kg. Next is the price of our raw material. The first material we use is the waste cooking oil. So here is the price list for different oil that used to produce biodiesel. As you can see, the WCO represent waste cooking oil is $224 per ton, while the price of waste cooking oil in Malaysia is around 20 cents per kg. So the second material that we use is the catalyst. While the catalyst we choose for this process is enzyme, while the model is Novosm 435. The price for this catalyst is around 52.57 ringgit Malaysia per kg. Now the third material that we use is methanol. So here is the price list for the methanol. While there's different price of methanol cost in different area, while in Asia there's around 38 cents per liter in Asia, while after convert into Ringgit Malaysia is around 2.1 ringgit per kg. And the magnesium, which is the last material that we use, is around 46 cents per kg. So here comes the site study for our location, for our project, which is the purpose of this site study is to compare different locations according to different perspectives and to select the most ideal location for our siting. So the first suggested location is Pengerang, Johor, which is indicated by this arrow. So this is the coordinate for the location. So here comes the advantage and disadvantage of this location. The advantage for this location is the availability of waste cooking oil is high, which is the raw material that we use, because there is some of the food manufacturing production industry in nearby of our suggested location. The second advantage is the availability of water resources is high, where the water resources or the cleaning water that we need is available. So the third advantage is a high local community consideration, where in Pengerang, there's no, it's a quite clear and empty area that less residence area there. So this will not give any noise pollution. And the fourth advantage is no climate change. Well, here comes the little disadvantage for this location where it's moderate distance from waste cooking oil producer to biodiesel production site. And because the distance is far, it might cost for the transportation fees. Here comes the second suggested location, which is Klang Selangor, which is same is indicated here. So this is the coordinate, and the advantage for this Klang is the siting is near to waste cooking oil producer, which is around 700 meters away from our suggested location. So it only needed low transportation cost, and similarly, it have no climate change. Well, the disadvantage is there's no water resources available for cleaning or cooling water that required for the process. So after some comparison and consideration, our final decision for the location site to build our industry is Pengerang, Johor. The reason we chose it is because it had high availability of raw materials, high availability of water resources, in a good climate, and had no pollution brought to the residence area.
So now I'll talk about the plot floor diagram. As you can see, this is the plot floor diagram for our biodiesel production plant. So first of all, the waste cooking oil will be treated with in the sedimentation tank and heating tank to remove mostly the water contained in WCO and the solid particles. After treating, the WCO will be sent to the PET bed to undergo triacidification with this methanol in the presence of this enzyme catalyst, which is Novozin. Next, the product will be sent to the sedimentation tank, whereby in the sedimentation tank there are two layers, which the top is the biodiesel layer, and then the bottom is the glycerol-rich layer. So the bottom layer, which contains the methanol, will be sent to the distillation column to recycle back the methanol. And then the top layer, which is the biodiesel-rich phase, will be sent to the batch reactor, whereby here magnesium will be added in to absorb the polar component, which is this methanol, water, and glycerol. And then coming to the filtration here to remove this magnesium, which already absorbed these three components here. Next, the biodiesel and the waste cooking oil will be sent to the distillation column to obtain the pure biodiesel. So this is our process flow diagram. As you can see here, we got two PET bed reactor here. This is because our residence time is long, which is 42 minutes. So once this reactor 1 is filled up, the valve will close the feed, so that the feed will feed to the second reactor, so that the process is continuous. The same case goes to the batch reactor here. So as you can see, this is the Aspen Plus simulation generated. So the purpose of generating this Aspen Plus simulation is to compare the mass balance of this Aspen Plus with the manual balance, which is going to be discussed in the following section.
This is the plan layout for our project. As you can see, there's a specific area for all the storage tank and reactor that located in this area. So to ease the transportation for our storage or our product, the warehouse and loading bay is just located beside the tank, and we had get fire station and assembly area ready in order to avoid any accident happen and for safety purpose.